before we begin the example, let's just recap what probability actually is. So we've got a Venn diagram here, a frequency Venn diagram, and we know that there's 20 people in a class and 2 people are in this set A. So we understand that the probability of A happening, or picking someone who's in the category A, is just 2 out of 20. Here we've got a probability Venn diagram, and we know that the sample space adds up to 1. So everything inside this box adds up to 1. So we know that the probability of A happening is, we're basically asking what fraction of the probability, what fraction of the total probability is in the A circle. So that's 0.1 as a fraction of 1, which is just 0.1. Well, what we're doing with conditional probability is we're doing a similar idea, but we're restricting the space that we know that we're in. So if we knew that we had A has happened, so we wanted the probability of B given that A has happened, well, we know that actually we're within this A circle, so we can ignore everything outside the A circle, and we're basically asking ourselves, what's the probability that B happens as a fraction of the probability of the region that we know we're in. So the probability of B happening is 0.2 as a fraction of the region that we know we're in, which is A, and the total probability of A is 0.5. So that's what we mean by conditional probability. So in example 5, we're asked to draw a Venn diagram to show the probabilities of events A and B. So let's draw a sketch of the Venn diagram. So we've got our 2 events, A and B. And we're told that in the intersection we've got 0.15. And the total probability within the A circle has to add up to 0.55. So we know that that must be 0.4. And the total probability within the B circle adds up to 0.4, so we know that must be 0.25. Now we need to include the region that's not in A and not in B, so this outside the circle region, and we use the fact that the total probability within the sample space is 1, and if we work that out, we'd get that that's 0.2 to make sure they all add up to 1. So in part BI, we're asked to find the probability that A happens, given that we know B has happened. So let's think about this in terms of regions on the Venn diagram before we use the formula. So we know that B has happened, so we know that we're within the B circle. So our denominator is going to be the total probability inside the region that we know we're in. So we're forgetting about all the probability outside of that circle and just pretending that our sample space is just this B circle. So the total probability within the region that we know we're in is 0.4. And we want, on the numerator, what's the probability that A happens given that we're within this circle? Well, within this circle, the region where A happens is this 0.15. So it's going to be 0.15 as a fraction out of 0.4, and we could simplify that as a decimal, and that's 0.375. If we were to use the formula, then the formula would tell us it's the probability of A and B happening divided by the probability of B happening. Remember, these aren't conditional probabilities. These are just normal probabilities looking at the Venn diagram. So we want the probability of A and B happening, which is 0.15, and divided by the probability of B happening. The probability of B happening is the total probability within the B circle, which is 0.4. So that's another method using the formula. In part 2, we're asked to find this quite complicated looking probability. So it's the probability that B happens given that we know A or B has happened. So let's think about it using the Venn diagram first before we use the formula. So we need to work out our restricted sample space, because we know we're only worried about the region where A or B has happened. So the region where A or B has happened, let's shade it in, is this region inside the circles. This is our region A union B. So we know that we're within this region. So we're going to ignore that 0.2 probability out there. So our denominator is going to be the total probability of the region that we know we're in, which is 0.8. If you add together these probabilities, you get 0.8. And on the numerator, we want, what's the probability that we're in B that's also within this region? So given that we're in this region, where can I be in this region where B happens? Well, that's in this section here and this section here. And the total probability of being in those regions is just the probability of B, which is 0.4. So we'd get our conditional probability is a half. If we were to use the formula, then it would be the probability of both of these two events happening, so the probability of B happening and the probability of A or B happening, divided by the probability of A or B happening. So the probability of A happening and A or B happening, let's try and work out what that region is. So we're going to try and sketch this region B and A or B. So we know that we're within the B circle. But we also want to be within this set, which is A or B. Well, A or B is anything within the circles, A union B. So actually, if I do the intersection of B and A union B, I just end up with B. So the numerator is just the probability of B happening, which is 0.4. And the denominator is the probability of being in the region A union B, A or B happening. Well, we know that that's 0.8. So you get the same answer as before. And then finally, we want to work out in part 3 the probability that A doesn't happen, given that we know B hasn't happened. So looking at the region on the Venn diagram, we know that B hasn't happened. So if we sketch what that region is, where B hasn't happened, we know that we're in this region, or we're in this region on the outside. So that's like our restricted sample space. We know that we're within these two regions. So we've got these probabilities, 0.4 and 0.2. So that's going to be our denominator, and the total probability is 0.6 for the region that we know we're in. So on the numerator, we need to work out, well, out of this region, where can we be to make sure that A doesn't happen, because we want not A happening? Well, out of these two probabilities, A not happening is this probability, 0.2. We have to be in that region. So the fraction of the probability where A doesn't happen is 0.2 as a fraction out of the region that we're in, which is total 0.6. And the probability of that is a third. We could use the formula. The formula would be the probability of A not happening and B not happening divided by the probability of B not happening. Well, the probability of A not happening, not A and not B, if we were to shade in that region, it would be everything outside of the circles. So that's 0.2. And divided by the probability of B not happening outside the B circle, the total probability outside of the B circle is 0.6. So you'd get the same answer of a third.